Module 4, end of module assessment. Abby is deciding which cell phone plan is the best deal for her to buy. Candy Apple Electronics charges a monthly fee of $8 and also charges 12 cents per call. She makes a note that the equation is M equals 1200 C plus 8, where M is the monthly charge in dollars and C is the number of calls placed. Around the World Cell has a plan with no monthly fee but charges 25 cents per call. She makes a note that the equation is M equals 2500 C, where M is the monthly charge in dollars and C is the number of calls placed. Both companies offer unlimited messages. So A is make a table for both companies showing the cost of service M for making 0 to 100 calls per month using multiples of 10. So first task we're gonna do is go through and highlight all the pieces excuse me, that go together. All right, so we have Candy Apple is an $8 monthly fee, 12 cents per call. So its equation is M plus 1200 C plus 8. And then we have Around the World Cell. It's 25 cents per call, so its equation is 2500 C. Okay, when you guys do this, this leads into going from a table moving into a graph. So we really want to make sure that we make sure we know which one is the y-axis and which one is our x-axis. So our x-axis is always first in our table, so it's our number of calls, okay, and then our y-axis is going to be our cost of services in dollars. That's going to be really important once we move into B, because we have Around the World doesn't charge a monthly fee, but Candy Apple does. We want to start with 0 calls. Okay, because even if I make 0 calls, I still have to pay $8. All right, and then when I'm trying to figure out Around the World, it would be 2500 times 0, which is $0. Okay, so and then it says it wants us to do it multiples of 10. So we're just going to go 10, 20, 30, 40, and so on. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Had a brain fart there for a second. All right, so now we want to figure out how much is it going to cost for Candy Apple. So we're just going to focus on Candy Apple for a second. It's going to be 12 cents per call. So if I have 10 calls and 12 cents, 10 times 12 cents is $1.20 plus the 8, and that gives us a total of $9.20. Okay, and then we do the same thing for 20 calls. So 20 times 12 hundredths is $2.40 plus the 8, so we get $10.40 as our total. Then we're going to substitute in 30 for C, and we're going to have 12 hundredths times 30, which is $3.60 plus 8 equals $11.60. We're going to continue on that same pattern each and every time. So this time we took 40 times 12 hundredths, so we got $4.80, plus the 8, we got $12.80. Okay, so let's pump over to Around the World. So Around the World, if it's 25 cents a call, if I make 10 calls, I'm going to take 10 times 25 hundredths, which is $2.50. Some of you guys are going to want to write that as 2 5/10, and I know that they're equivalent, but remember we're dealing with dollars, and dollars always go out to the hundredths decimal. All right, so then we're going to take 25 hundredths times 20, and we get 5, and you can do $5. Then we get 30 times 25 hundredths, which is $7.50. Then we're going to do 40 times 25 hundredths, and get $10. Okay, and then we're going to continue that pattern throughout. Okay, so here is the table completely filled out. At some point, you should have started to realize, hey, there's a pattern going on, that each time we're adding like $1.20, we added $1.20, added $1.20. If you're going to use the pattern, it's totally 100% fine. Just make sure that you do add that in correctly. If you're going to multiply every time, do your multiplication work. Don't do it mentally. Also on the test, you don't have to have this part. That was just me trying to show you how did we get $9.20. And then if you notice, the pattern over here is we increased by $2.50 each time. Again, just make sure that you do that correctly. Okay. So we now have our completed table. Okay. We want to go ahead and go to B, which is where it wants us to construct a graph for the two equations on the same graph. So this is a little bit different. You're going to use the number of calls C as the independent variable. Our independent variable is always our X, and then the monthly charge is our dependent variable, which is always our Y. Okay, so I want to make sure that we do that correctly. Okay, and all that is, in case you guys forget, is this money depends on how many calls that were made. So we don't get $8 or $9.20 if we don't know how many calls were made. Okay, so these numbers are dependent on the amount of calls that happen to be made. Okay, when you guys do this, there are a couple things you always have to have on a graph. You guys are going to have a title. You are going to have to label the X. You're going to have a scale for the X. You're going to have to label the Y, and you're going to have a scale for the Y. Okay, so we can just make a really simple title. All we're doing is comparing two phone companies. So we are comparing Candy Apple and Around the World. Okay, so pretty simple title. It just tells us what's going on in the table that we have. So now we're going to look at the X axis. Remember, we already know that the X is the independent variable, which is the number of calls. So we're literally going to name it number of calls. Make sure when you do this, give yourself space that you don't forget to have the label on there. Okay, and then we want to look at the y-axis. So I'm going to turn my paper just to the side because it's easier to write that way, and we're going to write monthly charges. Please, 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 please remember to tell me what you're measuring in. You can say in dollars, or you can just put dollars in parentheses. Don't put a dollar sign. Okay, but you need to make sure you have this labeled. If this was cups or ounces or teaspoons, we want to make sure that we label those things out. Okay, when we're trying to figure out our scale for our number of calls, we flip back to our X column. We're going to label 10, 20, 30, 40, and so on. So that one's pretty easy. So we start with 0. We're going to do 10, 20, 30, 40, 50, 80, 90, and 100. And I just staggered those so that I could clearly see them instead of them all looking like one big giant number. Okay, and then we're going to take a look now at what numbers do we have for both of these. So our smallest number we have is $2.50. Okay, and the greatest number we need to get to is $25. So we have to make sure that our graph kind of includes all of those different pieces on there. So when we look at our graph, we can count by twos and everything will fit on there. Okay, so what we're going to do is this would be 2. So we're just going to label every other line. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, and that gets us all of the numbers that we need on our graph. You have to remember this scale and this scale don't have to match, but we have to have the same continuous scale on the X, and then whatever scale we pick for the Y has to be continuous. So we can't go, oh, 2, 5, 7, 18, 94. We have to pick the same scale to go off of. Okay, and then your next task is we're just going to go ahead and plot these. Well, this is 0 and this is 8. Okay, so we're going to go 0 on the X and we're going to go 8 on the Y. And it's that simple. Okay, then our next one is 10 on the X and $9.20 on the Y. So we're going to go to the 10 and we're going to go to where $9.20 would be, which is somewhere right in here. Okay, and then you continue that same pattern for all the rest of the numbers. All right, so we've completed our graph line for candy apple. One of the things, because we're estimating and not everything is exactly on a line, your number might be a little hard to follow, but because we know we are increasing by the same amount each and every time, our line should be almost pretty straight. I'm a little bit off on kind of one of these, so I'm gonna fix that in a moment, but I should be able to draw a ruler line through those, and those should be at least pretty close. Okay, I'm not gonna go through and be like, oh, he's a little bit too far high or too far low. It should be pretty close to a straight line, and that's really the big takeaway for this piece. Okay, so we have our candy apple line. Okay, when you do this, you're gonna want to kind of make sure I know like which line goes with which equation. So this is the candy apple, which is M equals 1200 C plus 8. Okay, so making sure I know, like, somehow you identify which one goes with which equation. So then we're going to do the same thing that we did for around the world. So around the world, the first one is 0, 0. So our first location is 0, 0. Then we have 10, $2.50. So 10, this is 2, so it's going to be around here. And then we have 20 and 5. So 20 and 5. And then we have 30 and $7.50. That's not 5, Miss Brian. Sorry about that. This is 6, so this is 5. I was like, that's not gonna look right. And I noticed that because I was like, wait, I'm gonna have a huge gap, and I shouldn't have a really weird funky line going on. All right, so again, we just finished up all of our locations for around the world. Again, we should have a pretty straight line. Oh, I put my ruler too far over. Okay, a pretty straight line to follow. I didn't really draw that one on there very well. Okay, but this one, we just want to make sure we know this is the M equals 2500 C. Okay, some of you guys will just do them in 2 different colors so that we can see the difference between the 2 and so on. Okay, so that's your graph. Again, title, label, label, scale, scale, and all of your locations are on there correctly, which means if you put number of calls over on the Y, that whole thing, that entire graph is wrong. So you don't want to make that mistake, okay? All right, question C says, which cell phone plan is the best deal for Abby? Defend your example with specific, or defend your answers with specific examples. So what we look at when we look at this graph is at some point, one cell phone plan is better than the other, okay? So when we look, if we follow this line is cheaper, 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 cheaper until we get to around here, and then it's a higher price. You see how it's higher on the scale? It's at a higher angle and our cost is more. Okay, so at some point it becomes not effective to be doing around the world. So cheap, 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 cheap. Ooh, they're about the same. More expensive, more expensive, more expensive, more expensive. And then if we looked at candy apple, more expensive, more expensive, more expensive. It's higher, it's the higher line. And then, oh, about the same and cheaper, 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 cheaper. Okay. So what we're looking at is where's that point where those two almost meet. Okay. And that's how we would defend our answer. So it depends on how many phone calls Abby makes. If Abby's only going to make, 6 phone calls, okay, she's way cheaper down here because we would follow 6 until we hit our line, okay? And it's cheaper if she did that. And actually ignore every single thing I just said because not everything, I just said that last line backwards. Let's say she makes 10 phone calls. We're gonna follow 10 till we get to the line and it's cheaper. If we follow 10 to the line here, it's more expensive, okay? So this is kind of a longer explanation, okay? So you need to make sure you know where the break-even point is. On this particular example, we don't have one set number, okay? Our break-even is almost right here, okay? This would be pretty close to our break-even point. All right, on your guys' actual test, they will both be the same amount. Okay, so really it's probably like 48 and a half phone calls or something like that. Okay, so you're looking for at what point are both of these the same price? That's your break-even point. Okay, so who is better when you have less than the break-even? So these calls are less than our break-even point. So if we looked, that would be around the world is cheaper for these numbers that are above that break-even point. And then if you made more phone calls than the break-even point, we would just compare these pieces and we would look and say, oh, it's cheaper if we did candy apple. Okay. So when you do your explanation, you have to have all of those pieces in there. And that's why it said right here, specific examples. So you can't just be like, candy apple is cheaper when you make little calls. Okay, well, what to you is few calls versus your friends or your parents? Because your parents might think, oh, a couple calls or a couple texts is 10, and you think it's like 100, and that's a huge price difference. So the best deal. Okay, so let's break down this explanation so you guys can kind of see what's that whole picture look like. Okay, the best deal depends on the number of phone calls placed. So that's what we determine by looking at the graph. When we have our graph and they meet up, we know, oh, there's at some point, if you make fewer calls, it's better. If you make more calls, a different plan would be better, okay? You need to tell me what is that break-even point. So for us, it was around 60 calls. If we looked at our graph, that's about where they met, right here in the middle. And then if we looked at our table, okay, that's where they were about even, was at 60 calls, okay? So around 60 calls is the break-even point. So you're going to want to make sure you tell me that. Okay. And then you're going to want to make sure you tell me specifically if I make calls that are less than 60, which plan is better. So around the world is a better deal if her monthly calls are less than about 60 calls. Well, candy apple is the better deal when the number of calls is greater than about 60 calls. So you want to make sure you talk about, when is it better if it's less than 60 calls, and when is it better if it's greater than 60 calls. And remember that 60 calls was your break-even point. All right, number 2. Daniela is saving her money to buy a new TV, which cost $520. She already has saved $125. She earns $35 per week working for her mom and wonders how many weeks it will take her to earn enough to make her or buy her own TV. Okay, so we're going to make a table showing the number of week, or the week number, okay, which is W, and total savings, which is going to be S, in Daniela's account. Clearly, I didn't change the name out from previous years. So, a couple things that we want to make sure of. She wants to buy a TV, and it's going to cost her $520. So we need to make sure we know, hey, this is our total cost. This is what we want to get to by the end of our graph to give us an answer. She has already saved $125. Okay, so she already has that in her account. Okay, and then she earns $35 per week after that. And so we can kind of start plugging in all of our different pieces to make this work. Okay, so in the first week, we're gonna week 1, 2, 3, 4, 5, 6, 7, and 8. Okay, in the first week, she has the $125 that she started out with, and then she's gonna make $35 for that first week that she worked. Okay, don't forget that part, that she'd already saved $125, and then she's gonna work for a week, and then she's gonna add that $35 into her account. So this is $125 plus $35, and we get $160. Okay, and if you've noticed, I wrote it out because you do not want to do this mentally and mess up on week number 4, and then all the other weeks are wrong as well, and you lose a ton of points on your table. So please don't do these mentally. Okay, so then she works another week, so she gets to save another $35. So she was at 160. We're going to add 35 because we worked another week, and we get 5, 9, and we get 195. Okay, and then she works another week. So we've worked 3 weeks, so another $35. So we're going to take the 195, and we're going to add 35 to it. We get $230. Okay, so that pattern is just going to continue on each and every time. So there is our finished table. As you can see, we kept working. Now if we look at 8 weeks, we only have $405 saved, so we don't have enough for our TV yet if we've worked 8 weeks. But really the whole point of A for you guys to look at is, how do I complete the table? And we would obviously add more onto this table until we got to a large enough amount. So we're gonna skip down to B, okay, which says show the relationship between the number of weeks and Daniela's savings account using an expression. So if we're going to use an expression, you need to make sure you do not use an equal sign. We talked about that in the mid-module. If you use that equal sign, you lost a whole point. You went from a 4 to a 3, okay? So we wanna make sure that we don't do that, all right? We know that every week that we are working, okay, we are getting $35. So here's our $35 per week. So we're gonna take 35W, okay, and that tells us how much we make each week, but we have to remember, whoops, hit the wrong button. We have to remember that we had already saved $125. So that has to be added in, okay? So plus $135, okay? So this is our answer. You notice no equal signs, correct? None whatsoever, okay? But just in case you're wondering, all right, where did she get 35W from? That's because we made 35 per week. And the 135 came from what she had already saved. You don't need all this stuff. This is just in case you couldn't remember where I pulled that information from. Okay, and then C says, how many weeks will Daniela have to work to earn enough to buy the TV? And there's two ways that you can solve this. You get to decide whichever way you want. So I'm going to show you both ways so that you can see them. Okay, the first way is that you can just continue the table. Okay. So if we continued our table, okay, we have week 9, 10, 11, 12, and we'll just continue on. So we, at the end for week 8, we are at $405. So we're going to add 35 to that, which gives us 440. Then we worked another week, and so we can add another 35, which is 475. Then we worked another week, so we add 35, which is 510. And then we worked another week, so we add 35, which is 545. At week 11, we only have $510, which is not enough for us to buy the TV. Almost enough, but not enough. So we have to work a whole extra week. And you can't be like, oh, they worked 11 weeks in 3 days. They work a whole week, okay? So when we do this, Daniela will need to work 12 weeks to earn for $545. Okay, so you need to tell me how many weeks, how much is she going to earn, okay, which is $25 more than she needs. Make sure you include that last part, like, hey, she's making more than she actually needs to make, okay? The second way to solve this problem is to make our expression, take our expression and go ahead and turn it into an equation. So we know that we need to make $520. Okay, that's our goal, is to make $520. So that we would use our expression 35W plus 135, 125. Oh goodness, I messed that one up. Hopefully you caught that before I did on the video. This is supposed to be 25. 35 was how much we added each month. So just quick review. Sorry about that, you guys. It was 125, so we're adding 125, not 135. So caught that right at the end. So make sure you don't do that same thing on your test. You don't want to lose points because of attention to detail in those types of problems. Okay, so then what you would do is we're basically going to solve for W. Okay, we have to get rid of anything that we're adding or subtracting first. So we're adding 125, so we're going to subtract 125. These cancel. This becomes 495 equals 35W. Okay, and then we want to get W by itself. So this is being multiplied. So then we divide by 35, and we divide by 35. Those would cancel. Okay, and then if I did my division work, it's around 11 and 29 hundredths. Okay, you don't need to come up with the actual real answer, okay, because this is an approximate of what W is, which means you would have to round this to 12 anyways, because you can't work a partial week. We already said that when we talked about it over here. We're not working, 12 weeks and 3 days or 11 weeks and 3 days. We would round that up, okay? But the only problem with doing this is we don't end up with this sentence right here, which we need to do. So this can't be the end of what you do. You're going to need to actually plug it in. 35 times 12 plus 125, which is 420, plus 125, which equals $545. So you're going to have to plug in what you found out, what you decided 12 was, that it was 12 weeks, or that W was 12. Okay, plug it in so that you can figure out how much extra she made. So make sure if you decide to do this portion, you also plug it back into your problem. Okay, problem number 3. The elevator at the local mall has a weight limit of 2,500 pounds and requires that the maximum person allowance be no more than 11 people. This problem, people mess up because they don't read what each of the pieces needs to be talking about. So make sure that as you're going through problem number 3 on your test, that everything is on there that's supposed to be. The other thing that you want to take note of, that when you go ahead and write these inequality statements, we want that variable in the middle, okay, so that our problem works out much easier. So let's take a look at A. It says let X represent the number of people. So they already told us we're using the variable X. Okay, it wants us to write an inequality. Okay, inequality statements are your greater than, less than, greater than or equal to, less than or equal to. That's describing the maximum allowance of people. Okay, so we're talking about the people that are allowed in the elevator at one time. So when we look, okay, if we're talking about maximum allowance of people, if we go back into the problem, it says the elevator at the local mall has a weight limit of 2,500 pounds and requires that the maximum person allowance be no more than 11 people. So maximum person allowance is no more than 11 people. So don't talk about the weight on problem A. It will mess you up, okay? So we already talked about we're going to put our variable in the middle, okay? And we know that the maximum amount of people we can have is 11 people, okay? That means if that's the max, we can't have more than 11 people, okay? But we can have less than 11 people. So this is the number of people. We can have less than 11 people, but we can also have 11 people, okay? So we can have X is less than or equal to 11, okay? But that's not the only number that we could have, okay? Because we want to look at what are all the numbers in between there as well, okay? So we could also have an elevator that has 0 people on the elevator. So what we want to look at is what does that look like if we have 0 people in the elevator? So if we have 0 people, X can be what? It can be 0 has to be less than X, or it could be equal to 0. So we could have 0 people, okay? We could have 1, 2, 3, 4, 5, okay? So our expression, or inequality statement, excuse me, is 0 less than or equal to X, which is less than or equal to 11. Okay, so the number of people that we have has to be between 0 and 11 people. Okay, so B says draw a number line to represent all the possible solutions in part A. So when we look at this number line, we already determined that we can have 0 people in the elevator. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, okay? So now what you're going to do is you're going to fill in this number line. Here's the big thing. We are talking about people. So you can have 0 people and you can have 1 person, but you cannot have half a person. So it shouldn't be a straight line. You could have 2 people. You could have 3 people, but you cannot have 2.5 people. So each one of these represents people that we can have, okay? We can have 4, 5, 6, 7, 8, 9, 10, and 11 people. Don't forget to indicate with those data points each one of those people that are on there, okay? So then we pop down to C. And C says, let W represent the amount of weight in pounds. So again, they're telling us what variable to use. Okay, we're writing an inequality statement. So greater than, less than, greater than or equal to, less than or equal to describe the maximum weight allowance. So this time we are doing weight. And so we need to go back to the word problem. It says that the elevator at the local mall has a weight limit of 2,500 pounds. So we want to make sure those are the numbers that we are using for that problem, okay? So go back down here. Again, we're putting our variable in the middle, okay? So the weight of the elevator, if there's nobody in the elevator, it's going to weigh 0 pounds, correct? Okay, so our weight can be, it can't be less than 0. Okay, so 0 is less than W because you can't have greater than 0 if you don't have any people. Okay, and it could also be equal to 0 because we don't have any people, and that would work as well. All right, and then we look over here, and the maximum is 2,500. So the weight has to be less than or equal to 2,500. Okay, so again, the weight is going to be greater than or equal to 0. Okay, and then less than or equal to 2,500. Okay. All right, and then we want to draw a number line to represent all of the possible solutions in part C. So we're going to do our number line. And we're going to remember that we are going by thousands. So I'm just going to go by 500 because I don't really want to write a gazillion things. Okay? So 500, 1,000, 1,500, 2,000, 2,500, 3,000. Okay, and then I wrote it sideways, you guys, just so that, again, all my numbers weren't bumping into each other like we talked about earlier in the thing. Okay, oh, and you know what I forgot? 0. Okay, so we can weigh, we can have absolutely no weight in the elevator. So that is a closed circle, okay, because it's equal to it. So that equal lets me know it's a closed circle, okay? And then the highest, my greatest value, only gets to be 2,500. It can equal it, so it is a closed circle because it can equal it. And then you can have any weight in between because this is weight. So that's completely different than what we did with people. You could have, 500, 2.5 pounds worth of weight in the elevator. So you can have all those decimals and those digits in between. Okay, so this is a line. It's a solid line because we can include any of those measurements in between 0 and 2,500. Right? All right, problem number 4. Okay, says that Jameson's soccer team carpools for practice every week. This week it's his parents' turn to pick up the team members and then take them to the soccer field. Well, still staying on the roads, okay? Jameson, sorry, there's another mistake in there. Jameson's parents always take the shortest route in order to save gasoline. Below is a map of their travels. Each grid line represents a street and the same distance, okay? So we have Jameson's house and we have the soccer field. You're not gonna wanna like go over here and pick up 2 and then go pick up 4 and then pick up 3 and then come back to 1 and then go up here. We want to take that shortest distance. Okay, so Jameson's father checks his mileage and he notices that he drove 20 miles between his house and stop number 2. Okay, so between his house and stop number 2 is 20 miles. Okay, so when we look at this, okay, we know that however we get there is going to be 20. So I'm going to go this way on my grid, my graph. We're going to stay on the road, so no diagonal lines. We have to stay on a road. We're not going through a field. Okay? And then we get over here. Okay? You could decide, hey, we want to go up and then straight over. You're going to find that they're the same measurement, whichever way you decide to draw your lines on there. So it says create an equation, which means we're going to have an equal sign, and determine the amount of miles each grid line represents, okay? So the first thing you need to do is you're gonna create your equation and you're gonna use a variable. We're gonna use the variable G, okay? This tends to get forgotten, okay, that you don't tell me what your variable represents. So please don't forget that on your test. So G represents number of miles per grid line. And you could use X, you could use L, you could use W. It doesn't really matter what variable you use, but you need to tell me that it represents the number of grid lines. So again, we got that from here, okay? Each grid line represents a street in the same distance, okay? And that each grid line is the miles, okay? So we're trying to figure out how many miles each one of those lines represent, okay? So the second thing that you're going to do is you're going to create your equation, okay? So we need to count how many grid lines there are between Jameson's house and the second stop. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 grid lines, okay, that we traveled. So 10G. Okay, and like I told you, it doesn't matter which way you go. Let's say we went this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then we get 10G and it equals 20 miles because that's how many stops we had, or that's how many miles it was between his house and stop 1. Okay, so we're just counting our grid lines to get the number of grid lines. This is the second piece you need to have on your test. Okay, and then the third piece you need to have for answer A is you need to tell me what G represents. So we would solve for 2G equals 20. This is multiplying, so the opposite of multiplying is dividing. So divide by 10, and we get G equals 10. G does not equal 10. Miss Bryan cannot divide right now. G equals 2. Sorry about that. Okay, so G equals 2 miles. Don't forget to label that. Okay, you have to get a 4, you have to have all 3 parts. Okay, So if you want a 4, you have to make sure you have all 3 of those parts on there. Okay? All right, so then we take a look at B. And B says, using this method, or using this information, determine how many miles total Jamison's father will travel from home to the soccer field, assuming he makes every stop, and explain how you got your answer. So we're still using the same formula that we had. So the first step that we need to do is we need to count our grid lines again. Okay, so I'm going to zoom in nice and big so you guys can see it. We already know that there are 10 grid lines from Jamison's house to stop 2, but we'll just start from the beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and Miss Bryant, oh yeah, I'm not, 20 and 21. Okay, so there are 21 grid lines from Jamison's house until you get to the soccer field. Okay, so we know that from step 2 that means it's 21G. Okay, and that's going to tell us how many miles we're going to have to travel. So, okay, there were 21 grid lines. We already determined in problem A that G is 2 miles. So we just have to plug this in. 21 times 2 equals 42 miles. Okay, and to get a 4, you have to make sure you have both of those parts listed out. Okay, don't just write 42 miles, or don't just write 21 times 2. Like, you need to make sure you have the equation and then go ahead and do your substituting. And we got this 2 from problem A. Okay? All right, our last problem is C. Okay? And it says, at the end of practice, Jamison's father dropped off team members at each stop and went back home. How many miles did he travel all together? Well, you know, you can go back through and we can count all the grid lines, but we know from Jamison's house to the soccer field was 21 grid lines. So if Jamison's father is going to drop them all back off, he's going to go the same way, which is another 21 grid lines. Okay, which means he went for a total of 42G, okay, 42 grid lines. It's going to equal our miles. And then we can plug in 42 times 2 equals 84 miles, okay? And again, to get a 4, you need to do both parts. You need to show how you determined that the answer was 84 and not just write down 84, okay? All right, very last problem is number 5. Okay, it has to do with finding angles. Okay, so for a science experiment, Tristan reflects a beam off of a mirror. He is measuring the missing angle created when the light reflects off the mirror. Okay, so note that this figure is not drawn to scale, which means you cannot go, oh, this looks like 50 and this looks a little bit less. So we're gonna go with 47. Okay, it's not drawn to scale. This really is not 50 degrees and that's not really 101 degrees. So you need to actually do some math, okay? So it says use an equation to determine the missing angle labeled X in the diagram. One thing to make sure that you understand that a straight line is 180 degrees, okay? So anytime that you have a straight line, that's going to equal 180 degrees. So when we look at this, okay, if I start here, from here to here is 50. So I went 50 degrees. Okay, then I went from here to here, and that was 101. So I'm going to add those. because I went 101 more, and then from here to here is x, and I'm going to add x, and we know that a straight line, which is what we've basically created, okay, we've taken this and we've gone from here all the way around, so that we're that way, okay, back to a straight line, which is 180 degrees, okay. Then what you're going to do is you're going to go ahead and you're going to combine like terms. And these are numbers, so that means they are like terms. So we combine those and we get 151 plus x equals 180. I don't need the degree sign. I'm not sure why I put it there. Okay. Then you need to solve for x. And you do need to solve for x the Eureka way. We talked about how we've been solving for x, and I showed you kind of the easier way to set it up. You need to make sure on this test you do it the way that they want. So if we are adding, we want to subtract this, which means we're going to take 151, we're going to minus 151 plus x equals 180 minus 151. Because we subtract 151 here, we have to subtract 151 here. These things, these two basically will cancel out, so you're left with x equals 180 minus 151, which is 29 degrees. To get a 4, you have to have all 4 of those steps listed on your paper, and I just realized you can't see the bottom one. There we go. Okay, so this is important to make sure you set it up the way they want you to set it up, so you need to do all 4 steps. Okay, all right, good luck.